Today, we're going to learn how to make a low poly stylized fire effect like this in Unreal Engine using its Niagara Particle System. Start, we're going to open up our content drawer, right click, new Niagara System. I'm going to do minimal just so I can show you what every individual step does. Minimal is basically an empty system. Let's call this ns_fire and open it up. All right, if you're new to Niagara, I'll quickly go over what we're seeing here. Down here in the bottom, this is our timeline. We can pause it if we wanted to see what the system looks like at a specific time. But other than that, it's just going to keep looping over and over again. Over here is our preview of what the system actively looks like at the given time. I like to change this from Epic Headquarters, which is what it is by default, to gray wireframe. I also tweaked a couple things here. I've made the environment color black. I've disabled show grid. I've also disabled show mesh edges. This one here is a little confusingly named. It's basically like show wireframe. In my opinion, this kind of just dark void makes it a little bit easier to see what's going on, less of a busy background than the Epic Headquarters. In here, this is our actual, I guess you'd call it Niagara graph, but it's different than any other graph. We're not going to be wiring up any kind of pins or anything like that. Instead, we have two nodes right now. This is our system properties node, controls things for the entire Niagara system. And this is our emitter properties node. In more complicated systems, you can have multiple emitters, an emitter being the thing that spawns the particles. In this case, we are just going to have one. This is a pretty simple system, but it's still good to stay in the habit of staying organized. So we're going to rename this to fire. All right, now let's get things showing up on screen. We have 4 states to worry about and a 5th kind of weird state-like thing that I'll talk about in a second. But we have 4 main states that determine what's happening at any given moment for everything controlled by this emitter. First is our emitter spawn. This is basically begin play for the emitter. It runs once when the emitter spawns into the world. Emitter update is like our tick. It runs every single tick that the emitter exists for. And then we have the same thing for each individual particle. So each particle defined or created by the emitter is going to have its own begin play and its own tick, its own spawn and update. I'm also just going to come into our update here and dismiss this note. Gets rid of that little blue dot. In emitter update, so every tick of the emitter, let's add a spawn rate node. There we go. We got our little particle. Spawn rate will spawn, in this case, 1 particle every second that the emitter is alive for. Easy enough. Next, let's make our particles kind of float upwards, like, fire. So in our particle spawn now, we're going to add a new, it's called module. And this is going to be add velocity. Now, add velocity has some errors. It depends on a couple of other modules to exist, as Niagara helpfully tells us over here. It needs apply initial forces and solve forces in velocity. We're going to fix the issue for apply initial forces. Unfortunately, due to, I think, a bug, it clears the error, but has not actually solved the problem. We now need to come manually in here in particle update and add our solve forces and velocity. This basically just evaluates any physics that we've put on it, and this here applies any physics that we've created as a part of our spawn. All right, now we have particles that are just kind of drifting upwards. Let's make them a little bit more cone-like. It'll help create that kind of volume of the fire. So we change our velocity mode from linear to cone. And we see now they're going out kind of sideways here. I'll up the spawn count just so you can see it a little bit better. We can see it's creating this cone kind of out in the positive X. And that's because of the cone's axis. By default, it is 1, 0, 0, meaning that it points towards the X. let's set that to 0, 0, 1 to make the cone point up in the Z. Cool. And let's make it go a little bit faster too. I'm going to increase the speed to 30. Awesome. Now let's take down our spawn rate back to something like 3. Next, let's change the shape, and that handily brings me back to this fifth state-like thing called render. The reason I didn't cover it in the other, or with the other 4 states, is because no real logic happens in the render state. Instead, this just determines what each particle looks like. Internally, Unreal just thinks of each particle as an individual point, and it's this render state here that determines what we see where each of those points are located. By default, it'll be a sprite renderer, which is just a flat plane with some kind of material or image stuck onto it. We're going to change it to a mesh renderer. By default, it has this little axis thing as our mesh, which, fun fact, is called a gnomon, I believe is how you pronounce that. Learn something new every day. But we're going to change that to be a cube. And just for consistency, because Unreal has many cubes, we're going to use the... Oh, I didn't realize there was a particle cube. Let's use that. That sounds correct. Perfect. So now we got all these tiny little cubes floating around, but they're a bit too tiny. Back in particle spawn, we're going to go into initialize particle and come down here to mesh attributes. You see one of those is mesh scale mode. Set that to random uniform. And let's do between like 3 and 5. Cool. So now they're all tiny, but what I want them to do is kind of balloon out and grow in scale, and then they'll shrink back down right at the end. So in particle update, we are going to, what's it called here? There we go. Scale mesh size. Perfect. And here we have our scale factor, which by default is a vector in case we wanted to control the X, Y, Z individually. In this case, we don't. We want it to stay a cube. So we can click this arrow and do vector from float. Now we can just control one thing to control the scale of our meshes. But we want this to change over time. So we're going to click this drop-down arrow by our float that we made and do float from curve. This will now do a curve controlled by the particle's normalized age. Perfect. I'm also going to make the scale of our curve. Let's see, what's the biggest that I want to scale this by? Let's try 10. That might be too much. Let's try 5. Cool. And then I can also kind of predefine a template shape that I want to work with for our curve. I'm going to do this ramp up, ramp down. So we see it kind of grows and then shrinks. Now I want to give it a bit more personality. So I'm going to add a key here. So it kind of pops in. It's a little bit maybe too much pop, so let's drag it over. Let's see, what's this? 0.5, 1. So let's make it go to 1 at 0.1. And we can also define the kind of curveness of it and how it flows from one point to the next. Next, let's shift this over from 0.5 to be like 0.8. And that should help us get this kind of cool effect. I want it to be even more pronounced, so I'm going to move this to 0.9. So now they kind of pop in and then pop out. Cool. Now let's work on that material, since right now it's just kind of the default weird cobblestone thing. Also going to save it so I don't lose progress. Open up our content drawer, and now I'm going to create a material. M_fire particle and open it up. Drag it in from my other window. And this is going to be pretty easy. Fire shouldn't receive any light, so we're going to make it unlit. And let's see. I think I'll keep it as... No, you know what? I will make it translucent. Now, for particles, we have a couple of extra nodes in our material browser. First is just particle color. This will get the color of the particle as well as the alpha value. And then the other thing I want to do, since I want to be able to control the emissive separately from our Niagara, is I'm going to grab another node in here called dynamic parameter. And we have a special module for this in Niagara that we can control any of these parameters. You can have up to, I believe, as many as you want. You can change the index here. Super useful node. We're going to change parameter 1 to be our emissive mult, as the name might imply. We're going to multiply that by our RGB. Perfect. If we wanted to, we could also define a custom starting value for what this would be. In this case, 1 is just fine. Save it, head back into our Niagara system. To apply that material, we're going to go to Mesh Render, enable Override Material, add Override Material, break open these two structs, and find our fire particle matte that we just made. Little bit convoluted, but it works. Now, we can define its emissive, and then we'll define its color. So here in Particle Update, I'm going to add a dynamic material parameter node. I'm also going to keep it above solve forces and velocity. I like this to be the last node in the stack, just out of force of habit. And we see it's immediately found our emissive mult. Turn off these other parameters since we don't care about it. And by default, let's make it 1 again so we can see what's going on. Similar to our scale, we're going to do float from curve. And I want it to be related to this curve, so I'm going to look at it from a reference. I think that it should start off very high and then ramp down when we do this kind of fall off. That will also be related to color. Let's make it fall off at starting at 0.75. So in here, we have our 1. We're going to add a key at 0.75. And that's still going to be 1. And I want this to be auto. So we get that nice kind of curve instead of a straight line. So now we see the emissive starts to kind of fall off up here. Next, let's add some colors to kind of help sell that effect. Come in here, scale color. Did I make this translucent? I did. All right, cool. In that case, instead of scaling the RGB and the alpha separately, this would be great if we wanted to use those kind of curves we've been working with before for the RGB and the alpha. I think it's a little bit complicated to think of RGB as a pure vector instead of just being able to see color. So I'm going to change this to RGBA linear color and change this to be color from curve. Perfect. Now I have pulled up here a reference image of fire in my browser. So I'm just going to kind of color drop some stuff. Let's see. The whitest that I see is this hex code. Start there. The darkest that I see is this hex code. So we'll end there. And let's add some other stages in between. One thing I don't like about this kind of gradient, I guess I could look at the curve, but that kind of gets confusing, is that it doesn't give me like numbers. So it's a little hard to compare and be like, I know that at 0.75 in our normalized age here, I want it to start going smoky, kind of gray. So you just kind of have to eyeball it as best you can. I'm going to say 0.75 is there-ish. So I'm going to grab that color. I actually want to turn this down even further and desaturate it. There we go. And let's make this just, I was going to say totally black. Let's give it a tiny, tiny value, but very desaturated. All right, there we go. That looks pretty good. It's starting to fade into smokiness around the same time as the emissive turns down. I think I lined that up pretty good. Now let's give it some more color as it comes into being. I want this to be a little bit more of a yellowy orange. Let's grab that, my color picker there. Cool. And then we'll make it go to kind of a darker orange. Let's see. All right, now I can add my own kind of artsy vision here. Let's make this be a little bit less red, a little bit more of an orange. And this is just kind of the fine-tuning stage. I'm not going to spend too long on this, but you know, if this was your own particle system, you'd probably want to spend a bit longer fine-tuning this. I also don't love how frequently this is spawning in, this kind of like pulsing effect, so I'm going to just turn down the spawn rate. Another thing that you can do here is affect the spawn probability. This is just the percentage chance that a particle has to spawn. So if I kept this at like 4, but I changed it to like a 0.6, 60% spawn chance, now it's a little bit more random when we're getting these fires, or these fire particles. Now I want to go ahead and drag it in just to see what it's looking like. And as I can see here, it's pretty big. The one weird thing about Niagara, you cannot scale it like anything else. See, if I drag this scale around to be like 0.5 or even like 0 scale, this is the same. So it all comes down to managing this here and this here. So I'm going to reduce these to like 1, 2. Save it. Let's see. Does that affect it? It's a bit better. Still a bit big. So let's do like 0.5, 1.5. All right. Now let's also fix that kind of alpha fade out here. Come back in my scale color. Oh, did not mean to open it up. Don't look in there. Very scary. And let's add a node there so that it only starts fading out when it goes smoky. There we go. All right. Let's see what's next on my list. Cool. Last thing, let's give it a little bit more realistic motion. In Particle Update, we're going to add a node called Curl Noise. And yeah, that's fine in the order. This will kind of now randomize how those particles move. I'm also going to increase the spawn rate a little bit. Let's do 5 and like a 0.7 chance to spawn. That'll help us see what's happening a little bit better there. And we can see now they're kind of drifting out. I don't love how separated they are, though. Let's turn off our spawn probability. Let's see. There we go. I like that better. And lastly, let's add some rotation in there. So in our particle update, we're going to do mesh rotation force. And this one's going to get a little bit weird. What we're going to do, multiply vector by float. Our float is going to be our normalized age. And then the reason we're not just making this a curve is I want it to be random. So random range vector. And I also want to make sure that this is evaluating every frame. So now, and let's do like 1, 1, 1, 2, 2, 2. Turns cap block back off. Now, as the normalized age increases, we get more rotation. So meaning that the smoke particles start to actually rotate more and more. And that's too much. Let's try -1, -1, -1, 1, 1, 1. Let's see, how does that look? We get a little bit of rotation in there. And that's pretty good, actually. I thought this was a little bit too much, personally. So yeah, that's how to create a kind of voxelized fire particle effect. Obviously, you can art direct this to your heart's content. I recommend art directing it. If it were me, I would really go in and fine-tune those colors, fine-tune the spawn rate, fine-tune when everything is happening. I think this is like 80 to 90% the way there. It still needs that kind of final polish pass. But yeah, this is a good kind of just intro to Niagara idea. I highly recommend, if you're getting into Niagara, start with the elements. I hope to have a tutorial out on water soon that will also show how to do like collision with Niagara. So get subscribed to see that. And yeah, any other questions, please feel free to leave them in the comments below. And I will see you guys next time.